Hey kiddos, today we are going to be solving equations by backtracking. So basically we're taking it a step further than what we've been working on, which is one-step equations. And today we're going to be solving two-step equations. So all the same rules that we've been working with are still applying here. We're still going to be doing things like adding, subtracting, multiplying, dividing. The only difference here now is that instead of being able to solve an equation in one step, it's going to take us two operations. Okay, so reminder that finding a solution means we're looking for the value that when you plug that value back into the original equation, it makes it work. It makes it balanced. So both sides are going to be equal. So that's our whole reason for working backwards today. Our solving of two-step equations means that we are going to be looking at our variable and trying to isolate that. So the big thing that I use to explain to students how to do this is to think about unwrapping a present. So our variable is what we want, right? We want to get that value by itself. We want to know what that variable is worth. So if you think about a present, right, it's wrapped up in a box, there's wrapping paper, sometimes there's a bow. So in order to solve the equation, we're always going to start with what's on the outside. We're going to take the bow off first, and then we're going to unwrap the wrapping paper. We're going to take the lid off, and then finally we're going to get to our variable. So when you're looking at a problem and you're trying to figure out where should I even start? How do I start this problem? Always think about what's furthest away from the variable and then work your way in. So what's the bow, right? What's the wrapping paper? What's the lid? Start furthest away from X and work your way in until eventually you get that variable all by itself. Okay, so we're going to look at some examples. So our first example right here, 2x plus 3 is equal to 13. Remember, that's a balanced equation. So I'm going to create a nice workspace by drawing a line down from the equal sign. And we're going to ask ourselves, if I want x by itself, what do I need to do working backwards to get rid of everything else that's around x? So again, I'm going to start with what's furthest away from x. So I'm going to get rid of the plus 3 first. The opposite, working backwards, of plus 3 is to subtract 3. Because these are equal, this is a statement of equality, I'm going to subtract 3 from both sides to keep everything nice and balanced. If I do it on one side, I have to do it on the other side. So the plus 3 and the minus 3 cancel. This 2x is going to come down. And on my other side, 13 take away 3 is going to give me positive 10. Okay. Now, again, I ask myself, how do I get x by itself? What do I have to get rid of? So right now I have 2 multiplied by x, and I don't want that 2 there. So I'm going to do the opposite of multiply, which is divide on both sides. So on this side, the 2 and the 2 cancel, and x is left over. And finally, I get what I wanted. I wanted that x by itself, and that's what I have now. And 10 divided by 2 is 5. Now, again, we have our value for x. To check my work, if I wanted to, I could take that 5 and plug it back into the original equation. 2 times 5 is 10, plus 3 does equal 13. So we know we did this problem correctly. Okay, let's look at another example like this. Here we have our variable on the other side, and that's okay. Some students think that the variable always has to be on one side, like it always has to be on the left side for the answer to actually be valid. It does not. So on this problem, we have our variable, which is b, and it's on the right side, and that's okay. We're still going to use the same procedures. So I want b by itself. I need to get rid of everything else around b, so I'm going to start with the minus 8. The opposite of subtracting 8 would be adding 8 to both sides. Again, it's balanced, so if I do something to one side, I have to do it to the other side. Negative 8 and 8 cancel out. The 5b is just going to come down. And 17 plus 8 is going to give us 25. Now, in order to get b truly by itself, I have to get rid of this 5 now. And right now, 5 is being multiplied by b. 5 is multiplied by b. So in order to get rid of multiplication, I'm going to divide by 5. If I do it on one side, I have to do it on the other side. The 5 and the 5 cancel out, so now b is finally on its own. And 25 divided by 5 is going to give us 5. Okay. We have one more example like this. One more example where we have a pretty straightforward problem where we're doing two operations. Again, two-step equations means I need 2 steps to solve. Again, I have a balanced equation here. There is a statement of equality, so I'm going to draw my line down the middle, down the equal sign. And then I have to ask myself, if I want S to be alone, to be isolated, I have to get rid of these other things. So how do I get rid of those things? I'm going to start with the minus 10. To get rid of subtracting 10, I do the opposite, which is adding 10. To keep things balanced, if I do it to one side, I have to do it to the other. Hopefully this procedure is becoming repetitive so that you're building that muscle memory of how to do problems like this. The negative 3s is going to come down, equals 20 plus 10 is going to give us 30. Now, normally we would want to get rid of what's in front of s, and here I have a negative 3. The negative 3 is being multiplied by s, so I'm going to go ahead and divide by negative 3 all at one time. Okay, I'm going to divide by negative 3. And it's completely okay to divide by a negative number. There's nothing wrong with that. So the negative cancels, the 3 cancels, and s is left over. And then 30 divided by negative 3, that's the only thing you got to be careful with. A positive divided by a negative means the answer is negative. And 30 divided by 3 gives us 10. So s is equal to negative 10. Now, all of those examples were pretty straightforward. Didn't really have to do anything fancy with those. We're doing two operations. We're either adding, subtracting, multiplying, or dividing, and we're doing it twice. Now we're going to introduce problems where we actually have to do some different things. Okay, so we might have to distribute. We might have to deal with a fraction. Okay, so let's look at a couple examples. We're going to step it up a bit, just make things a little bit more difficult. Now, our first problem is going to involve distribution. Now, whenever you have a problem with distribution, there are actually two options here. You can either divide if both sides are divisible by the number you're distributing, or you can distribute. Okay, now I usually distribute, even though my students like to divide, just because distribution works all the time. It works all the time. Dividing only works if this number in front can be divided into the number on the other side. Now in this case, 4 does go into 12, so I'm going to actually divide. So I'm going to divide both sides by 4, and remember the reason I'm doing that is because multiplication, right? That's what distribution is, can be undone by dividing. So instead of multiplying by 4, I'm doing the opposite, which would be dividing by 4. The 4's cancel, and then I bring down x minus 6 outside of the parentheses. 12 divided by 4 is going to give us 3. That's a weird looking 3, but that's okay. And then I have to get rid of the minus 6. That's my last step. So to get rid of subtracting 6, I'm going to add 6. The negative 6 and the 6 cancel out. X is by itself. That's what I wanted. And 3 plus 6 is going to give me 9. Okay. Now, our next example, I'm going to look at what we would do if we actually distributed. Now, remember, this is an option. It's not mandatory, but this is another option just to show you what you could have done. So anytime you have a problem with distribution, you always could distribute. That's an option. Now, even though negative 5 will divide into 20, I'm going to actually distribute. So when I distribute, I multiply negative 5 by what's in the parentheses, so that becomes negative 5n, and negative 5 times positive 1 is negative 5. Now, the reason we distribute again is because now I have something very similar to the problems I was starting out with at the beginning of this lecture. So I can use what I did at the beginning of class to solve this. First, I'm going to get rid of the plus or the minus 5 by adding 5. So on this side, the right, the minus 5 and the plus 5 are going to cancel out. Negative 5n is going to come down. And on the other side, 20 plus 5 is 25. And now I have one more step. I'm going to divide because I want to get rid of what's in front of n. So I need to get rid of that negative 5. To get rid of multiplying by negative 5, I'm going to divide by negative 5 on both sides. The negatives cancel, the 5s cancel, and n is left over by itself finally. And 25 divided by negative 5 is going to give us negative 5, because again, a positive divided by a negative equals a negative. So that's another option. Now I could have divided by negative 5 at the very beginning and I would have got the exact same answer. It's completely up to you what method you want to take. You can either divide like we did in this example, or you can distribute like we did in this example. Okay, we have 2 more examples and they're going to involve fractions. Now this first example is very straightforward. It involves a fraction, but we're actually not interacting with the fraction yet. Again, we're looking at our variable and we're thinking about what's furthest away to start with. So I'm not going to start with the 3 that's in the denominator. I'm actually going to start by getting rid of this positive 4. To get rid of adding 4, I'm going to subtract 4 from both sides. So x divided by 3, then plus 4 and minus 4 cancel out, is equal to 9 minus 4 is 5. I didn't realize how many 5s I had in this lecture. I must be biased. So x divided by 3 is now equal to 5. And I know I want to get rid of the 3 on the bottom. So I ask myself, if I'm dividing by 3, what's the opposite of that? The opposite of dividing by 3 would be multiplying by 3. I'm going to do that on both sides. So the 3's are going to cancel out and x is by itself finally, and 5 times 3 is going to give us 15. Okay, now on that example, we did not really have to interact with the fraction at the start of the problem because there was something else that was further away, so we dealt with that first. Our last example is a bigger fraction, and if you notice, x is now in the numerator of the fraction and our denominator is 5. Okay, so there is no term that's added or subtracted to the fraction. It's one big fraction. And so when I'm thinking about x, 3x minus 7 is the numerator. That means this is all together. So I need to actually get rid of the 5 first before I can do anything with that top of the fraction. Okay, so again, I have to get rid of the 5 before I can do anything with the numerator. So to get rid of dividing by 5, I'm going to multiply by 5. If I do it on one side, I have to do it on the other side. The 5's are going to cancel out, and the numerator of the fraction is what's left over. 3x minus 7 comes down. 4 times 5 is 20. And now I'm basically back at what I started with at the beginning of the class. I have a 2-step equation that I can work with. So I'm going to get rid of the minus 7 first by adding 7 to both sides. Minus 7 and plus 7 cancel, so 3x is equal to 27. And I'm running out of space here. I'm going to try to cram it in. I need to get rid of the 3. The 3 is multiplied by x, so I'm going to divide by 3 and divide by 3. These are going to cancel out. I'll work over on the side here. The x is now equal, 27 divided by 3 is going to be 9. And that is going to be our solution. Okay, so with 2-step equations, remember, always start furthest away from the variable. You want to work your way in, isolating that variable, and finally getting to an answer that's going to work as the solution to the equation.